Hi everyone, my name is Caitlin Welch and I'm a project engineer with Hoyle Tanner & Associates. We were retained by the town to design the bridge replacement for the Wellington Road Bridge over Converseville Brook. Today I'll be walking you through the proposed bridge rehabilitation and replacement options. This presentation will cover goals of the project, who we are as a company, our experience with this type of project and who our project team is, funding through the New Hampshire Department of Transportation State Bridge Aid Program, 3 different alternatives that we investigated, anticipated project schedule, and the best way to reach us with your questions and concerns. We are in the early stages of the design process for this project and would like to share as much information as we can with the public. During this presentation, our goal is to make sure you understand the proposed options for rehabilitation and replacement of the bridge, as well as the accompanying details of each option. We would like to listen to your concerns and input and answer any questions you may have. Contact information will be provided at the end of the presentation. We are a New Hampshire-based engineering firm with our headquarters in Manchester. We have been in business for 47 years. We previously designed the replacement of the North Street Bridge in 2003. I did not personally work on that project, but Sean James, our principal in charge for this project, was the project engineer for that project at the time. For the design of our bridge projects, we work closely with an experienced staff of transportation professionals to ensure the roadway meets local, state, and federal guidelines. As a group, we have worked on and designed a variety of bridge structures from small culverts anywhere from 10 feet in span to large highway bridges up to 400 feet long. For this project, we partnered with Doucette Survey, who performed a topographic survey and wetland delineation of the area, and SW Cole Explorations, who performed the subsurface exploration adjacent to the existing bridge. As a firm, we have successfully designed over 100 bridge projects funded through the New Hampshire DOT State Bridge Aid Program, which I will cover in the next slide. The project team consists of Sean James as principal in charge, Joseph Beecha as project manager, and myself as the project engineer. I have personally worked on over 15 bridge projects over the past 3 years. Joseph has designed over 80, and Sean has worked on over 60 bridge projects funded by this program. The graphic on the right of the slide shows all the different towns we have worked with throughout the state. The number in parentheses indicates the number of projects. The majority of the project funding will come from the New Hampshire DOT State Bridge Aid Program. The remainder will be funded through local funds. The State Bridge Aid Program has certain requirements and steps that we have to follow. It starts with preparation of an engineering study, which is what we are currently working on. After the study is completed, it goes to the New Hampshire DOT for their review and approval. When the approval is received, we continue with next steps, which are preliminary design and permitting, final design, bid phase, and finally construction. Each of these steps has a submittal that needs to be reviewed and approved before we continue with the next steps. Listed here are the general requirements for the program. For all bridge rehabilitation and replacement options that we have investigated, all of the requirements will be met and no design exceptions will be necessary. I want to take a moment and explain the freeboard to the 50-year flood event, as I realize that could be confusing. The New Hampshire DOT requires that there is at least 1 foot from the 50-year flood elevation to the bottom of the bridge, and this is referred to as the freeboard. Goals for the project include designing for a 75-year service life for the replacement options and 20+ years for the rehabilitation alternative. Other goals include providing an adequate waterway opening that accommodates the 50 and 100-year storm events, a low maintenance structure and roadway, and a structure that can carry all legal and state certified loads. We investigated several bridge rehabilitation and replacement options while considering to minimize the construction duration, project costs, and abutter and environmental impacts. For this project, we will be impacting the wetlands and will need to obtain a permit from the New Hampshire Department of Environmental Services. According to NHDES, the proposed bridge must be able to accommodate a 100-year storm event, the stream banks must be vegetated, and the bridge span must be equal to 1.2 times the bankful width of the stream. These requirements are calculated through a detailed hydraulic analysis and generally result in longer bridge spans. The existing bridge was built in 1950 and consists of two 12'6" span by 7'6" rise corrugated metal pipe arches. The two culverts are approximately 50 feet long and run parallel to Converseville Brook. Due to the corrosion and loss of steel on the bottom of the pipes, as seen on the photo on the right of the slide, the channel bottom is undermined or scoured at both ends of each pipe. This condition makes the bridge structurally deficient, which will continue to deteriorate if not properly fixed. The bridge has been posted to allow only 3 tons or passenger cars across it since July 2018. The traffic is relatively low at approximately 800 vehicles per day, according to New Hampshire DOT records. Here are some photos of the existing culverts. The photo on the left depicts the undermining or scouring of the channel bottom at the ends of the culverts. The photo on the right depicts one of the 2 spalling concrete headwalls and also a sinkhole that has started to develop behind the headwall. The topographic survey and wetland delineation were recently completed by Doucette Survey. The survey details where all existing features and areas of wetlands are located. A subsurface investigation was completed by SW Cole Explorations in February of this year, and it revealed that the soils under the roadway surface are suitable for shallow concrete foundations. Bedrock was encountered between 19 to 26 feet below the ground surface adjacent to the bridge. As mentioned previously, a hydraulic analysis was completed to determine what size structure would accommodate the 50 and 100-year storm floods. We also looked at several bridge rehabilitation and replacement options that meet the project goals. The first option that we investigated is to rehabilitate the culverts by reusing the existing metal pipes. The bottom of the inverts would be lined with reinforcing steel and concrete would be casted to prevent further corrosion. Short concrete walls would be installed at the ends of the culverts to prevent future undermining of the culvert, and a stone weir would be built downstream to control channel flow. This rehabilitation would provide a 15 to 20-year service life for a total project cost of $498,000. We have designed a similar concrete lining project as shown in the photo on the right for the town of Belmont. Their culvert was similarly deteriorated but closed to traffic due to condition. By installing the concrete invert, we were able to improve the condition of the culvert, which has now been in service for 8 years with no change in condition since it was originally installed in 2012. The first replacement option is concrete abutments with pre-stressed concrete beams. The concrete abutments would be formed and cast in place at the site, and the beams would be constructed in a controlled factory environment with high quality materials. This option would open up the span to 35 feet and would increase the service life to 75 years. The estimated total project cost is $1.33 million. The photo on the right shows this structure type for a project that we've recently designed for the town of Salem. The second replacement option is a precast concrete arch. The arch would also be constructed in a controlled factory environment with high quality materials, and it would be placed on footings cast in place at the site. This option also increases the span to 35 feet and would have a 75-year service life. The estimated total project cost is $1.09 million. The photo on the right shows this structure type for a project that we designed for the town of Lyndeborough. Our recommendation is to replace the bridge with the precast concrete arch. It is the most cost-effective option that provides a relatively maintenance-free bridge, and it meets all of the New Hampshire DOT State Bridge Aid Program requirements. Approximately 300 feet of roadway reconstruction will be required, and we are recommending a complete roadway closure in the vicinity of the project with a 5-mile-long detour. Here is the roadway plan depicting the recommended structure with the anticipated roadwork limits. The paved roadway width will be very similar to what is there now, but the bridge width would be decreased from 50 feet to 33 feet. There will also be more guardrail as shown on this plan in order to meet the current design standards and to also protect motorists from driving through steep slopes near the bridge. Here is the roadway profile showing how the elevation of the roadway will mimic the existing roadway surface. The bridge pavement and subbase would be reconstructed for a total length of approximately 300 feet. Here is the elevation view of the new bridge and how it would look. Note the form liner that we are showing is used to make the concrete look like stone. Here is the typical bridge section. You can see the rail on each end, the 13-foot travel lanes, and the 2-foot wide shoulders. The concrete arch will have a gravel fill on the top and pavement for the riding surface. The project schedule is anticipated to start with preliminary design and permitting from May to September of this year, then continue with final design from September to December. The project will be put out to bid in January 2021 and awarded to the contractor in February. Construction of the bridge will likely take place from May to mid-September 2021. And that concludes this presentation. Please reach out to Joseph Beekja, the project manager, or myself at the contact information provided with your questions and concerns. We look forward to hearing from you. Thank you.